All right, good morning, everyone. So, today's video is going to be fairly short. Just meant to talk about a few little things that we didn't get to cover in class yesterday, as we spent some more time on some bigger ticket items that were a little bit more important. These topics, more so, are just a small part of things that you could potentially see in a multiple choice or a free response question, but aren't necessarily the most crazy, super important topics that you could see in terms of linear regression. So far, we've already talked about those, right? Being able to interpret correlation or just interpret any sort of relationship, right? Your strength, form, direction. And also, if there's anything unusual, right? If you have any outliers, you do want to make sure that you talk about those, as well as influential points, right? So anything unusual, being able to interpret r squared with your r squared percent of the variation in y can be explained by its relationship or by its linear relationship with x, as well as being able to read that awkward printout, which we're going to take another look at today. And those are really the biggest things that you could potentially see in terms of a linear regression type question. However, there are a couple of little things that I do want to make sure that we cover, just so that no matter what happens on the AP exam, we are prepared for anything, right? So the first little thing that we can talk about here is interpreting the Y-intercept in a given question, right? And so much like, if you remember, right, interpreting slope, all right, let me just erase this, redo this here. So interpreting slope, right, we are interpreting the change in y per 1 unit x, right? And obviously here we're filling in the blank for y and x in terms of the context of the question, right? I don't know why my stylus decided to freak out there for a moment. We're just going to rewrite that. There we go. Much better. And that's fine. Now, for the y-intercept, what we want to make sure we talk about, right, is when our explanatory variable equals 0, our predicted, and here's the key, your predicted y value, right? I feel like oftentimes, especially in some of the responses I've seen to free response questions, we speak very much in certain terms with regression. And while regression is a significantly more concrete topic than, say, describing a histogram or a box plot, we do need to be careful, right? As evidenced by what we talked about yesterday, we need to use what the AP exam calls non-deterministic language here, right? There's a predicted increase. There is on average it increases or decreases by, things like that, because remember, this isn't a perfect r equals 1, a perfect line scenario, right? So we can say here the predicted y value. Now remember, again, I'm only using this language of explanatory variable just to reinforce some vocab so we don't forget. Explanatory variable is just x, whatever your x is here. So another thing that's important about that is oftentimes they will ask you to interpret in the context of the problem. And a key thing here is that it's okay if it doesn't make sense. It is totally cool if it makes no sense, right? So for instance, if your x variable, right, if our explanatory variable is years, and let's say they start in the year 2010, well, year 0 in terms of your model doesn't make any sense, right? Oh, well, if this scenario happened 2,000 years ago, right, doesn't always make a lot of sense. Oftentimes, we'll be dealing with real world quantities, so having negative of something doesn't make a whole lot of sense, right? Now, if it's money, that's one thing. But if you're talking about, how many apples grow in an orchard during a given time of year, a negative amount there makes absolutely no sense. So it's totally okay if in the context of this question, whatever it may be, your y-intercept makes absolutely 0 sense. The only thing you have to make sure of is that if that's the case, make sure you mention it in your explanation, right? If it makes no sense, make sure you say, in the context of this question, this doesn't have any real meaning because we can't have negative amounts of apples or negative amounts of cars, or crickets can't chirp negative amounts per minute if we're using the same example that we used in class yesterday. So that's the short bit about how to interpret the y-intercept. It's pretty easy, just again, making sure we use that non-deterministic language, right? We're saying that's the predicted y value, not it is the y value. So another vocab thing I want to make sure we talk about is interpolation and extrapolation. I don't know why my stylus is having a rough time here, but let's try that again. Much better. Right? Interpolation versus extrapolation. Now, you may have heard these terms before, but all interpolation means is predicting between two known x values here. Right, so I'm trying to predict the y value between two known x values of the problem. So, for example, let's say I had a table here. I'll just make one really quick. And let's say we had 1, 2, 4, 5, and I had some y values here. And I said, find y hat. Remember that stands for our predicted y value when x equals 3, right? So this right here, this finding the predicted y value when x is 3, is considered interpolation because it's within two known quantities, right? I'm between 2 and 4, right? I don't actually have a data point at 3, but I'm going to try and predict it using what I know. Extrapolation, on the other hand, is predicting or trying to make a prediction outside. And again, my stylus doesn't like writing here. All right, we're just going to have a large space there. Predicting outside of your data set. Meaning, right, less than your minimum or greater than your maximum x value, right? So either less than your minimum or greater than your maximum. These are just vocabulary terms. So again, if I pull the same table here, right, if I said, so 1, 2, 4, 5, and then 7, 8, 12, 27. 2 examples of extrapolation would be something like find the predicted y value when x equals 7, or find your predicted y value when x equals 0, right? Both of those are outside of your data set, right? I don't know anything when x equals 7, right? It's larger than my maximum. Same thing with 0, it's less than my minimum. I've seen a few multiple choice questions where they ask you to, classify a prediction as interpolation or extrapolation. I've seen it on a free response question where they ask you to find a predicted y value and then explain, is this an example of interpolation or an example of extrapolation? So, I hope this makes sense, right? If you have any questions, please either write them down on what I'm going to have you submit or save them so we can talk about them on Wednesday. Now, one thing I did want to look at in terms of this interpreting the y-intercept, there is a very, very recent free response question here from 2018 that tells you, if we look at part A, identify and interpret in the context of the problem, the estimate of the intercept, right? As well as, if you look at this question, this is exactly what we talked about the other day. So what I'm going to have you guys do, it's just these 3 parts, right? This is going to be your assignment to work on. So try that, do your best, right? And notice part C. why would this point be considered an outlier? So think about that discussion that we had yesterday in terms of residuals. All right. I hope you guys have a wonderful day, and I'll see you all online tomorrow. Bye, guys.